Let me demonstrate a couple of questions really quick. Here we would take the square root of both sides like we normally would, which gives us x equals plus or minus the square root of -5. We pull the negative out there, and what it allows us to do is get the square root of 5i. So there are two answers. It's the plus and minus of the square root of 5i. It becomes quite simple to work with I, actually, especially because we just did so much of this before. I would divide both sides by 4 here, and I would get x squared equals -4. Then I would take the square root of both sides. And at this case, I would get x equals plus or minus the square root of 4 times the square root of -1, and x equals plus or minus 2i. Because the 4 comes out perfectly as a 2, right? So again, nice clean solutions and answers. Let me show you two more. Let me work through these ones. I would first move the 6 to the other side, giving me -6. I would then next take the square root of both sides. And that leaves me with x minus 2 equals plus or minus the square root of -6. I've learned the little trick here, though, is what I do is I get the square root of 6 times the square root of -1, and so I get plus or minus the square root of 6i. And then I move the 2 over, I get 2 plus or minus the square root of 6i. Here is the real part of my complex answer, and here is the imaginary part. Let's do the next one. I would move the 12 to the other side. I would then divide both sides by 3, and I'm at x plus 1 equals, all squared equals -4. I would then take the square root of both sides, and what that would leave me with is x plus 1 equals plus or minus the negative square root of 4, square root of -4, sorry. And then again, I'm going to split out that value to get the -1 away from the 4. And again, I just keep moving my way down until I get my final solution. And there it is. There is the part that is the real part and the imaginary part of my solution. These are quite fun. I hope you get them and enjoy them.